So here are some references for the topics that we were discussing. So first, linear algebra method. An excellent reference book is Linear Algebra Methods and Combinatorics by Laszlo Babai and Peter Frankl. So this book unfortunately is never been printed formally, but its preprint is available preprint is available online from I think Babai's or Frankel's one of them website. So it's a very nice book, and I know the presentation is also very nice with lots of insights and many nice questions. We will look at a couple of results from this topic, and then the second topic we were looking at is the probabilistic method. So this topic has at least two good books that I know about, and the most important and most interesting one is the probabilistic method. I know the name itself is the probabilistic method by Noga Allen and Joel Spencer. It's a beautiful book, very nicely written, and the first and foremost reference for anybody looking at probabilistic method. Then there is another book, Graph Coloring and Probabilistic Method, by specifically targeted to graph theory people. But of course, many tools can be learned for the combinatorics from this as well. And this is by Mike Molloy and Bruce Reed. This book is also interesting, especially for graph theories, but one should be careful. There are several typing mistakes and careless mistakes in some parts of the examples, but not on the theorems. So only when you are looking at examples, you should just work out the details and see whether what is proved is actually correct. But it's a nice book anyway. Then another powerful technique is the polynomial method. Now this is an emerging area, and there is a new book on this. The third book, which I mentioned, is Polynomial Methods and Combinatorics. Is a book by Larry Goods, and it's a beautiful book which is based on a lecture series that was given by Larry Goods in a couple of years. And this covers the topics that we have mentioned, and the topics that is covered in the earlier papers on which this method is this book and several of techniques from the method in polynomial method is used based on. So the start of this is basically from this combinatorial nutshell and stats from Noga Allen, and this paper is available from its website, and it lists a beautiful collection of applications of this method. And then the second book is by Ziv Duel, Incidence Theorems and Applications. I mean, it's not a book; it's a paper again. It's also available online. And the third one is, as I mentioned, the Polynomial Methods and Combinatorics. It's a book by Larry. Then we have Advanced Graph Theory. There are several good books on this. The one that I want to mention is Algebraic Graph Theory by Goldstill and Royal, which talks about specifically on algebraic techniques related to group theory and things like that. Then there is Extremal Graph Theory by Bela Balabash, which has a lot of results and very powerful tools. And then there are several books on graph theory. I will mention two of them here. One is Graph Theory by Adrian Bondi and U.S. Armoti, which is a very famous book. And then there is another beautiful book by Reina Distel. again, both having the same title, graph theory. Then, of course, Introduction to Graph Theory by Douglas, which is a book for anybody who want to start this topic. It has a very readable material, very easily readable, and also very advanced topics as well. So it's a nice book by Douglas. Then other topics on graph theory more specialized, like one can look at like random graphs and complex networks by Hofstede is a book, more recent one. Again, I think it's available online. And this it's actually a 2-volume book, quite large. Talks about large networks and then looking at random tools from probability as well as some other topics on random graphs. And there is a whole theory of evolution of random graphs, etc. And then it has applications on large networks, and then the networks grow, what happens and all comes clear. And because the behavior becomes predictable using tools from probability theory, because the thing itself is quite random. And then we have and when the network size is very large, there is nothing else we can do, right? Practically we cannot go and dig into the graph and then study its properties easily. Then we need to use this kind of. Then a very standard and classic book by Bela Bosch, is Random Graphs. Again, books by Bela Bosch is not not very easy to read, but it is an excellent book and source for a reference as well as for people looking at more advanced. Then Fan Chung has written a book, Spectral Graph Theory, which is a nice book. And then there is another by Grover, Spectra of Graphs. These are on so related to graph, one can define some matrices like Laplacian of the graph, and then this Laplacian matrix you can look at the eigenvalue spectrum, and then studying the spectrum one can talk about the properties of the graphs. Some other many other related matrices and tools are also there. Then we have extremal combinatorics, which looks at extremal set theory or extremal questions. Like for example, like sunflower lemma or Erdo's-Colorado theorem. These kind of results are beautiful results and very powerful results from extremal set theory. So here are some nice books. The first book is an excellent read and very easy to read and very nicely written. Extremal Combinatorics with Applications to Computer Science is the full title. And it's by Stasis Dukina. It's written in a very beautiful manner, and it has a nice collection of lots of exercises, questions, and results. And presentation is so beautiful and very easy to read. Then Combinatorics of Finite Sets by Anderson is a short book on extremal combinatorics, and then there is also a book Hypergraphs by Volobash. Now hypergraph may be a misleading term, because hypergraph is not really graph. As we mentioned very briefly in our graph theory parts, like hypergraphs are basically set systems which we want to call as graphs to just look at in some related questions are there. So therefore, hypergraphs are basically set related questions, and it's basically extremal set. Then enumerative combinatorics, of course, the most beautiful reference on this is enumerative combinatorics by Stanley. There is volume 1 and 2. Volume 1 itself is it's a short book, but it has a lot of content, and then volume 2 is even more with lots of additional tools and examples, and it's a very comprehensive book, a very good reference book, and very beautifully written. Stanley's writing is so clear that one has to admire, like how the clarity of vision helps you when you read also. And then a course in enumeration by Martin Egner is a very standard book on enumerated combinatorics, which is also very readable with lots of exercises and questions. Then another very good writer is Miklas Bona. He has written nice books. A walk through combinatorics is a nice book. Then here is another one on enumerative and analytic combinatorics, and this is also a very good read and easy presentation, and lots of advanced results as well. Then we have Ramsey theory. In Ramsey theory, we have a couple of several books are there, I think, and here I am presenting just two of them. One is by Alexander Soifer. Soifer's book is not probably a good textbook, but it is a very readable book which introduces you to the subject, talks about the history, talks about why such questions are important and how these questions are there, who looked at these questions first, and how these things came about. And then, while doing all this in history, he talks about and introduces a lot of questions, lot of fun questions, and then references, techniques, and all. But better read for the subject as it is if you want to study from a book and then look at references. Is another book again titled Ramsey Theory by Ronald Graham, and then Rothschild and Joel Spencer. I forgot the first name of Rothschild. Sorry about that. Then we have Analytic Combinatorics. Analytic Combinatorics by Philippe Flageolet and Robert Sedgwick. And this, Flageolet is very, he writes very beautiful books, and then he passed away unfortunately, I think, before the publication, but the book is available online for free and one can download it. It is a very nice book, a very large book. It's a good reference book as well as a readable presentation of the material with lots of exercises, examples. Then related to this, one can also look at maybe the book called Generating Functionology. Generating Functionology. So this is the title of the book. It's a single word that I have written, and this book is by, I think, Herbert Wave, if I remember correctly. I'm not 100% sure now. Hilbert Wave, yeah, Hilbert Wave. So this is again a nice book. You can learn many tools from generative functions, and it's a good reference on that, as well as a book which also related to analytic combinatorics because it is mostly about generative technology. Finally, we have the design theory. There are several books. I am not much familiar with the books on this topic, but one good book on this is Combinatorial Designs by Douglas Stinson. There are many other books in balancing, complete block design, etc. And one can look at this for at other places. Okay, so that's all, and then we now go to look at these two topics that we wanted to look at on linear algebra method and probabilistic method. Yes, so that's what we are going to